Hi everyone, Martin here. Welcome to the Inner Loop. In this episode we're going to look at dropping perpendiculars on a triangle and making some big fractal pattern. This is kind of what I'm after. You drop a perpendicular on a right angle triangle and you drop another one, another one, another one, another one, and eventually you should end up with something like this. We'll leave Coder Martin here, hacking around in the background, and come and visit him when some interesting things happen. Let's see if we can do the maths of this again quickly. The question is, I've got a triangle. I'm going to drop a perpendicular to this line to here. I know this point, I know this point, I know this point, but what's that point? What I do know is I know the slope of this line, and because I know the slope of this line and I know these are perpendicular, I know the slope of this line. So let's write that down. Let's do this line in blue. That's blue. We'll do this one in red. So this is our interesting point. The blue line equation is y equals mx plus c. The red line equation is y equals x over m plus d. It's got a different intersect. This point here, xp yp, is what I want to work out. Here, p. M I know, because I know this point, x1, y1, x2, y2. So m is equal to y2 minus y1 divided by x2 minus x1. So we can save that, but we know what that is. So now I can work out d. I can work out d because because I know this point, x3, y3, d is y3 minus x3 over m. D equals y3 minus x3 over m. So to find this point now, this point is when these two are equal. Mx plus c equals x over m plus d. M I know. So what I want now is the x value. So mx minus x over m this is where I went wrong before. The gradient of this line is minus 1 over m. So d is actually equal to y plus, and this is equal to minus x m. Same mistake twice, plus d minus c. So I can solve for x now. X into m plus 1 over m equals d minus c. So xp equals d, which I can work out, minus c, which I can work out, d minus c, divided by m plus 1 over m. And when I've got xp, I can work out yp from either of these. Yp equals m xp plus c. And c, I didn't do c, but c is equal to y1 minus mx1. So I've got all the ingredients I need to calculate that point. Back to coder Martin, and at this point I've managed to make a triangle with one side. Here I've managed to make a triangle with 3 sides. Here I've actually managed to make the perpendicular, but it's going in the wrong way, because I've still got that error with the minus gradient. Turn off the screen some direction. Now look at me. My head's going sideways because the perpendicular isn't quite perpendicular. What I've done here is I've made a mistake with the fraction underneath. It should have been m plus 1 over m, and I've put 1 plus 1 over m. One other little interesting side is when you have a triangle and you drop a perpendicular, you end up with 2 triangles. So you start off with a function, you give it triangle 0, and out comes triangle 1 and triangle 2. So the progression of this is 0 gives you 1 and 2, but then you've got to work on 1 and 2. So 1 is going to give you 3 and 4, and 2 is going to give you 5 and 6. This is generation 1, generation 2. The next generation, you work on 3, 4, 5 and 6, and that gives you 7, 8, 9, 10, 11, 12, 13, 14. Scratched my head a long time on this to try and make this work, and what I eventually came up with is you have a number here incrementing, call it I. So I just increments each time, but this value of I is I to the what is it? It's 2i plus 1. And this one is 2i plus 2. So 2 2s are 4, 5, 2 2s. And this number just keeps, this is your generation, 1, 2, 3, 4. So this adds up. And that's how I solved it. So this is kind of fractal. Every time you cut one up, you've got to cut up some more. So that was what I put in the code in order to generate these numbers in this sequence, 6, 13, 14, etc. Just a little side. So finally I worked out how to create the generation codes, and at last I finally saw the picture. And here we are, you can see me changing it in various different ways. Now I've finally finished, but there's an issue. I can't work out why it's not showing me lots and lots of levels. I mean, it's only going so far and then leaving lots of holes in the triangles. But what I haven't realised at this point is that I'm actually making the lines thinner for each generation, and the lines have actually gone to 0 width. It took me a few more days to work that one out. What follows now is 3 videos of the final triangles kind of in motion, and the last one is actually of 2 triangles back to back, making a really interesting square. Hope you enjoyed this, and thanks very much for watching. I'll catch you next time on the In Loop.